Now let's talk about the physics effects that are important to understand when planning and executing a draw shot. First, let's look at how backspin changes with speed and distance. With fast speed and short distance to the object ball, we lose very little backspin on the way to the object ball, and we get good draw action. Notice how the cue ball stops in place before the backspin gradually draws the cue ball back. At slower speeds, the backspin wears off more on the way to the object ball. Even though we're hitting the cue ball well below center, this is actually a stop shot because all of the backspin wears off. With even less speed, the cue ball can start to develop forward roll. Again, we're hitting well below center, and the cue ball starts out with backspin, but it wears off completely, and the cue ball starts to roll forward, resulting in slight follow. With a larger drag distance to the object ball, more speed must be used to retain the backspin. But with a low tip position and fast speed, we can still easily get good draw action. In slow motion, you can see the backspin slowing slightly, but not much is lost. With less speed, we'll lose more spin and get less draw. With even less speed, we lose all of the backspin and the cue ball develops complete forward roll, resulting in follow. The shot starts off with significant backspin, but it gradually wears off due to cloth drag. When no spin remains, the ball is said to be in stun. Then the cue ball gradually picks up topspin, eventually resulting in complete forward roll. The amount of backspin and draw also depends on the tip contact point on the cue ball. With a low hit, we get good draw action. Some of the backspin wears off on the way to the object ball, but enough remains to create draw. With a higher tip position, we create less backspin and get less draw. The cue ball starts with less backspin and it wears off gradually, but at this speed, some spin still remains at the object ball. Here's an even higher tip position, but still below center. Here, there's not much backspin to begin with, and some wears off, so little remains for draw. One way to control draw distance is to use the same tip position on every shot and just vary your speed. This is a good drill to use to try to improve your draw distance control. Start with a short draw distance and try to increase it gradually. Now let's look at how draw changes with cut angle. When a shot is straight in, we can draw the cue ball straight back. As the cut angle increases, the angle at which we can draw the ball becomes more limited. Let's look at a range of cut angles with the same amount of backspin. For thin cuts, we can't draw the cue ball back from the tangent line much at all. Speed also affects the path of the cue ball. At slow speeds, the cue ball draws back almost immediately with almost no shift down the tangent line. With more speed, the cue ball persists along the tangent line longer before drawing back. Let's look at a range of speeds, seeing the effect on the cue ball's path. If the quality of draw were the same for each of these shots, all of the lines would be parallel. In other words, the final draw angle would be the same. This illustration shows the effect more clearly. The red path is at a slower speed, and the blue path is at a faster speed. Each shot has the same quality of draw. With more shot speed, the cue ball persists along the tangent line longer before curving to the final direction. But the final direction or angle is the same for all three shots. Conditions also affect the draw path. With a brand new and clean cue ball on a slick cloth, the cue ball will persist longer along the tangent line. Also, less spin would be lost on the way to the object ball, so the draw angle would be steeper. To simulate slick conditions, we've sprayed a cue ball with silicone spray. First of all, here's a shot with the cue ball without the spray. And here's the result for the silicone sprayed ball with a similar speed and tip position. As you can see, the cue ball shifted down the tangent line much farther, and the draw angle was a little steeper. Cue elevation has an interesting effect on draw shots that we haven't discussed yet. But before looking at this, let's try a fun drill. The goal is to bank the object ball from the foot spot off the head cushion and draw the cue ball back to the foot cushion without having the object ball touch the foot cushion. This is a tough challenge with the cue as level as possible, but it is doable. The shot requires maximum draw at just the right speed. Here are two good but unsuccessful attempts. And this is what it looks like when it's done really well. If you elevate the cue, you can impart a similar amount of backspin with less forward speed. This can create the same amount of draw with slower object ball motion, making the goal of the drill much easier to accomplish. However, you don't get much benefit at small elevations. But at large elevations, the effect can be dramatic. Another cue elevation effect is cue ball hop. When using fast speed at close range to the object ball, the cue ball will be airborne when it hits the object ball. This causes the cue ball to hop forward, reducing the effect of the draw. At small elevations, the effect isn't very significant. However, as you increase the elevation, it can become more difficult to draw the ball. Here, the cue ball loses a lot of its backspin as it hops forward of the object ball. And with more elevation, the cue ball can go quite a bit forward and have little or no draw.